Assalamualaikum warahmatullahi wabarakatuh. I am Nisa Naswa binti Azhari, a final year student of Forensic Analysis. The title of my final year project is Isolation of Chemical Constituents from the Leaves of Macaranga hypoluca Euphorbiaceae, and I am supervised by Prof. Dr. Norizan binti Ahmad. Let me start with the introduction part. In short, the research is about phytochemical study of Macaranga hypoluca. Phytochemical study was done by chromatographic method then spectroscopy method to isolate and elucidate pure chemical compounds that will act as medicines. Two plants that have been studied and determined as therapeutic plants, which are Amaranthus spinosus L. as Bayam Berduri and Carica papaya L. as Beti. In this research, genus Macaranga plant was studied where its benefits are treat swellings and wounds, act as antioxidant and anti-cancer. In addition, Macaranga known as Pokok Mahang, while Macaranga hypoluca known as Pokok Mahang serindi. Now let's move on to the problem statements. First, the previous study done by Nazari and others resulted in the isolation of 3 flavonoids, a coumarin, and a phenolic acid. Second, the Macaranga hypoluca species are reported to have an abundance of phenylated flavonoids and stilbenoids that have intriguing biological activities. Thus, phytochemical study on the leaves of Macaranga hypoluca may be proceed to uncover a number of additional flavonoids or stilbenoids. Significant study. This study helps to add new information for medication, thus helps future researchers to learn more about Macaranga genus. The objectives of this study are: first, to isolate the phenolic compound from Macaranga hypoluca; second, to elucidate the isolated pure compounds from the species. Scope of study. There were 2 methods used, which are chromatographic and spectroscopic methods. Chromatographic methods consist of VLC, TLC, and CC, while spectroscopic methods are done by FTIR, UV-Vis, and 1D NMR. Literature review. First, the Euphorbiaceae family. Euphorbiaceae is a spurge family of flowering plants. This family appears as monoecious herbs, trees, and cactus-like. In Malaysia, there are 70 genera and 364 species of Euphorbiaceae. Second, genus of Macaranga. Macaranga is a fast-growing, soft-wooded species evergreen trees that has the height up to 20 meters, and some species are mere mesophytes. Moreover, this genus is known as pioneer trees on lots of damaged area or ground. The distribution of Macaranga. Macaranga genus is very widespread throughout the world. Mostly it is located in tropical Africa, Madagascar, Southeast Asia, Australia, and Pacific region. Furthermore, 8 different species found on Penang Island. From the table shown, the species are Macaranga tanarius, javanica, lowi, denticulata, trilobite, gigantea, hypoluca, and amisa. As you can see, Macaranga tanarius is the most abundant species, while there are only 24 plants of Macaranga hypoluca species were found. Fourth, traditional uses of Macaranga. Macaranga genus is useful for human health. Those studies written in the slide prove that Macaranga hypoluca is one of the therapeutic plants. The chemical constituents of Macaranga hypoluca. There were 4 flavonoid compounds that have been isolated successfully from Macaranga hypoluca by Nazari and others. 1. 8-prenylneraganin is obtained as a yellowish sticky solid, and it was isolated before from Macaranga cozy plant. 2. 6-3-hydroxy-3-methylneraganin is a brownish sticky solid and is the first time this compound have been isolated from any plants. 3. Saccharonatin is white solid, and Dodonia angustifolia was the species that it has been isolated before. 4. 7-O-methyl diacetol is a dark yellowish sticky solid, and before this, it was isolated from Heliotropium sinuata. Let's move on to the methods part. The Macaranga hypoluca leaves were obtained from UiTM Jengke, then ground and air-dried. The methanol crude extract was subjected to VLC for fractionation. The best solvent system used is hexane ethyl acetate. Column chromatography used for purification and yield 2 pure compounds, which are MH1 and MH2. Results and discussion. Phytochemical study on Macaranga hypoluca resulted in the isolation of 2 flavonoids, where MH1 is camphor and MH2 is quercetin. Those compounds were analyzed using UV-Vis, IR, and NMR. 30.8 mg of MH1 was obtained as yellowish brown powder. It is a flavanol named camphor. This compound was also successfully isolated from Rosa rugasa plant and Flos gossypi plant. IR and UV-Vis spectrum of MH1. IR confirmed the functional groups of camphor. 4 important absorption bands of camphor are 3245.2 InverCm due to broad hydroxyl group, 1658.9 InverCm a stretching band of carboxylic group, CH-sp3 stretching bands at 2923.1 InverCm, and 1169.9 InverCm the stretching band of CO. The carboxylate group bands depicted that camphor is a flavonol. Meanwhile, UVVs identified the positions, types, and number of substituents in conjugated systems. Two main maximum absorptions, which are caused by electron transition of cinnamon group at 369.97 nm and electron transition of benzoyl group at 254.68 nm. Proton NMR. As shown in the slide, I only focus on 5 peaks where it indicates the camphor. The appearance of doublet signals at 6.243 ppm and 6.508 ppm indicates the presence of 2 protons in the metal coupling position with the value of 2.0 Hz. 6.243 ppm referred as H6, while 6.508 ppm referred as H8. Moreover, at 6.996 and 8.126 ppm consist of 2 protons each. Those 2 peaks are considered as doublet ortho coupling position with the value of 9.0 Hz. H3 prime 5 prime located at 6.996 ppm, while H2 prime 6 prime located at 8.126 ppm. And those peaks showed the AA prime BB prime system since they are symmetrical protons in ring C. The most important signal peak is at 12.216 ppm because it depicted the chelated 5OH. The carbon NMR. There were 13 signal peaks appearing in the spectrum, thus representing 15 carbons of camphor. C4 is a deshielded carbon of carbonyl group at 175.839 ppm. Meanwhile, C5, C7, C4 prime, and C9 are known as oxocarbons since they are carbons bonded to O. C6, C8, C2 prime, 6 prime, and C3 prime, 5 prime are aromatic carbons and yields methane signals negative, while C2, C3, C10, and C1 prime yields positive signals as quaternary carbons. Furthermore, the analysis of proton and carbon NMR of MH1 were compared to the study done by Adarokba and others to determine that the structure is camphor. Since the data of mine are identical to the study done by Adarokba, it can be confirmed as camphor. The bioactivities of camphor are it helps in lowering blood glucose and it inhibits alpha amylase and alpha glucoside. Next, 0.4 mg of MH2 has been isolated and elucidated that known as flavanol named quercetin. This compound was also isolated from Aesculus indica fruit and Lagenaria caesararia fruit. IR and UVV spectrum of MH2. IR confirmed the functional groups of quercetin. 4 important absorption bands of quercetin are 3387.6 inverse cm due to broad hydroxyl group, 1654 inverse cm a stretching band of carboxylate group, CHSB3 hybridized stretching bands at 2924.8 and 2860 inverse cm, while 1011.4 inverse cm the stretching band of CO. The carboxylate group band depicted that quercetin is a flavonol. UVVs identified the positions, types, and number of substituents in conjugated system. Two main maximum absorptions, which are caused by electron transition of cinnamon group at 370.26 nm and electron transition at benzoyl group at 254.29 nm. Next, the proton NMR. As shown in the slide, there are 6 proton signals that are important as quercetin. The appearance of doublet signals at 6.262 ppm and 6.534 ppm indicates the presence of 2 protons in the metal coupling position with the value of 2.0 Hz. 6.262 ppm referred as H6 while 6.534 ppm referred as H8. The integration values of H6 and H8 are 1, meaning that there is 1 proton each. Moreover, this compound consists of the presence of ABX moiety as 1 doublet metal depicted at 7.825 ppm with 1.5 Hz as the coupling constant, 1 doublet of doublet depicted at 7.708 ppm with coupling constant values 9.5 Hz and 2.0 Hz, and 1 doublet ortho at 6.994 ppm with 8.5 Hz coupling position. In addition, the most important peak is at 12.183 ppm that pictures the chelated 5OH. Unfortunately, there is limitation for carbon NMR spectra for compound MH2 due to the presence of insufficient amount of sample to conduct the experiment adequately. Furthermore, the analysis of proton NMR of MH2 was compared to the study done by Abdullah and others to determine that the compound is quercetin. The data of mine and the author are identical, thus the research can be used as a reliable journal to confirm that it is quercetin. The bioactivities of quercetin that have been reported are: first, it acts as positive control for most of the anti-inflammatory activity tests, and second, in vivo, quercetin and its 2O-methylated metabolites might protect the cells from oxidative damage. Last but not least, to conclude my presentation, two compounds have been successfully isolated from the leaves of Macaranga hypoluca using vacuum liquid chromatography and column chromatography. Those compounds, MH1 and MH2, were elucidated as flavonols named camphor and quercetin using UV-Vis, FTIR, and NMR spectroscopy. These are the list of references that I used for this presentation. That's all from me. Thank you.